Welcome students. Now we'll discuss about module 3rd for the second year BSc Agriculture Honors for subject Agricultural Engineering for 3rd semester. The course code is COMP 231 and the title of the course is Agri-Informatics. The name of the module is Data Representation, Number Systems, Binary, Hexadecimal, difference between the ASCII and Unicode, that is different encoding systems. I am Mr. Vinod Adkari, Assistant Professor at Don Bosco College of Agriculture, Goa. The outline of this module is data representation, number systems, that is two binary and hexadecimal, difference between ASCII and Unicode, that is different encoding schemes. At the end of this module, student will able to learn about different types of data representation, different number systems, difference between ASCII and Unicode. So what is the difference between this qualitative and quantitative data? So we can refer a qualitative data are measures of types and may be represented by name, symbol or number code, like name of students, address of that student, like this mobile number. All these are the qualitative data. So it is not proportional to any value, represents quality or characteristics. But in quantitative data are the measures of values or counts and are expressed as numbers. Quantitative data are data about numeric variables like how many, how much, how often. So quantifiable, proportional to some values. Number of students, for example, marks of that particular engineering course or CGPA of that student are the quantitative data. So next is the types of numbers. We can classify numbers in two types, like that is the non-positional number and positional number. Non-positional numbers, in early days human beings counted numbers on fingers. When the counting beyond 10 fingers, then they are using some stones or pebbles or sticks to indicate the values. This method of counting uses an additive approach and it is known as non-positional number systems. So like I can use one line for number 1, 2 lines for second number, like this. So each symbol represents here the same value regardless of its position. We have to count the number of symbols present in the numbers. So it was very difficult to perform arithmetic with such number systems. Hence positional numbers are very developed. So positional numbers systems are the only 10 symbols from 0 to 9. So 0, 1 to 9 numbers, 10 symbols are there. These symbols represent different values depending on their position they occupy in that number. Either it is unit position, 10th position, like this. The following three considerations determine the value of each digit in the number: the digit itself, the position of that digit in the number, and the base of the number. What is meant by this base? Base is defined as the total number of digit available in the number system. The first digit is always 0 in the positional number. Positional numbers we can classify into 4 types, that is the decimal numbers, binary numbers, octal numbers and hexadecimal numbers. Now we'll discuss all these 4 positional numbers in details. So first is the decimal numbers. There are 10 digits in the decimal number 0, 1, 2 up to 9. In this decimal number system, successive position to the left of the decimal points represents unit, that is 10 position, 100, 1000 position. So each position represents a specific power to the base 10. Here in decimal number, base is equal to 10. For example, if I am taking number 2586, so it will be right as a 2586 to the base 10. It is consist of the 6. In this number, 6 is in unit position, 8 is in 10th position, 5 is in 100 position and number 2 is in 1000 position. So we can write this number like this: 2 into 10 raised to 3 as it is on 1000 position, plus 5 into 10 raised to 2 as it is in 100 position, plus 8 into 10 raised to 1 plus 6 into 10 raised to 0 as it is in unit position. So we can simplify it, we can get this same number 2586. So like this numbers are written in the decimal system. Next system of writing number is the binary system. In binary system, always value of base is equal to 2. In decimal it is 10, but in binary base is equal to 2. Hence, it has only two symbols or digits, either 0 or 1. The largest single digit in the binary system is equal to 1, which is less than the base. Base is equal to 2. Each position in this binary number represent a power of the base, that is 2. Hence, in this system, the rightmost position unit, it is equal to 2 raised to 0, which is the first position. The second position is equal to 2 raised to 1. Like this, the position of the numbers are written. So suppose I am taking the number 10101. So this number will be written in this binary number like this. So we can convert it into decimal also. So here bit is the short form of binary digit. We can use bit, either 32-bit or 64-bit. So that bit is the binary digit. So bit in a computer terminology means either 0 or 1. So every computer stores numbers, data, letters and other special characters in the binary form only. So some conversion of binary into decimals are given here. Suppose 000 number is there in binary, we can convert only single 0 in decimal. So like 011 number in binary, we can convert number 3. So like conversion is given here, 011 to the base 2 is equal to 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0 is equal to 3 to the base 10. Base 10 means decimal and base 2 means binary. So why it is 1 into 2 raised to 0? Because it is at unit position. So number 1 into base into unit position plus number 1 into base into next position, 100 position. Like this, numbers are derived from binary to decimal. Next is the octal number system. As name itself, the base is equal to 8 in this octal number system. Hence, there are only 8 symbols from 0 to 7. 0, 1, 2, 3, 4, 5, 6 and 7. There are 8 digits. 8 and 9 does not exist in this system. Like decimal, it is there. The largest single digit in this octal number is 7, which is less than base. Base is equal to 8. Each position in this octal number system represent a power of base 8. So here, like I'm taking example of this number 2057. We can write this number like 2057 to the base 8 in octal system. So we can convert this number from octal to decimal like this: 2 into 8 raised to 3 plus 0 into 8 raised to second plus 5 into 8 raised to 1 plus 7 into 8 raised to 0. So we can convert this number into decimal. It is equal to 1071 to the base 10. So likewise, some conversion will be asked in exams also for few marks. Next is the hexadecimal number system. So here, as name itself, it has a base is equal to 16. So here 16 symbols or digits are used. First 10 digits are the numbers like decimal number system, 0, 1, 2 up to 9, 10 digits. Next remaining 6 are the symbols, that is A, B, C, D, E and F, 6. So total 16 symbols or digits are there. So we are giving some representation value for that A, B, C, D. For A is equal to, in this table I am giving here red color, A is equal to 10, B is equal to 11, C up to F. So final 16 digit, 16 symbol, that is F is equal to 15 value. So the largest digit is equal to F or 15 we can call, which is less than base 16. So likewise, number systems is adopted in the hexadecimal number system. I am taking one example. I have this code 1AF. I have to convert into decimal. How the procedure is given here? 1 into, as there are 3 digits, no? So we have to take second power here. 16 is the base. So 1 into 16 raised to 2 plus a into 16 raised to 1 plus f into 16 raised to 0 as f at first position. So we'll get this number 16 square is 256. So we'll get the derivation and the number of this equation 431, which is in decimal. We have to put base 10 for this number. So likewise conversions we have to do. We already studied all these number systems from decimal, binary, octal and hexadecimal number system. Next part is the encoding decoding. So there are different kinds of encodings like ASCII, Unicode, base 64, these examples. For example, if we want to convert 91 number into binary, then it would become 110111. But what about other characters like A to Z and small a to capital Z and other things, or like star, or like dollar, percentage sign I have to convert. So that we have to use the encoding system there. So like these examples better will understand here. Whatever this binary code is equal to the good morning friends in the decoding system. So here we will see the difference between these two things, ASCII and Unicode. It is a character encoding standards for electronic communication. ASCII stands for American Standard Code for Information Interchange. It supports only 128 and 256 characters only. Uses 7 bits to represent a character, and it requires less space than Unicode. ASCII is of two types. Either it is 128 or 256 characters. But in case of Unicode, it is a computing industry standard for consistent encoding and representation. It stands for Universal Character Set, and it supports a range of characters, not only 2 characters, which is in ASCII. Requires more space or memory, and few examples of this Unicode like UTF-8 or UTF-16s like this. So these are the references for this topic. Thank you.